Welcome, OChemNinjas. As we move through organic chemistry, we're going to be asked to classify molecules. Descriptor words describe a single molecule, mesomolecule. In terms of definitions, a mesomolecule is a molecule that has more than one stereocenter and has a plane of symmetry, or can be rotated into having a plane of symmetry. A multi-stereocenter molecule is, yes, superimposable on its mirror image. If we reflect this molecule through a mirror plane, it doesn't look like the mirror molecule is superimposable on the original. But if I do a 180-degree vertical pancake flip of the molecule, the mirrored molecule is completely superimposable on the original. This is the same molecule drawn 3 different times. This one molecule drawn 3 times is meso. It's not always convenient to try and draw the mirror image and try and rotate it to be superimposable, so the other mnemonic is a molecule with more than one stereocenter and has a plane of symmetry, or can be rotated into having a plane of symmetry. This molecule doesn't look like it has a plane of symmetry, but if I do a 180-degree bond rotation around this carbon-carbon bond, that rotates the terminal carbon down to the southern hemisphere and rotates the dash OH group up onto the wedge. And now this molecule does have a plane of symmetry. This one molecule, now drawn a total of 4 times, has more than one stereocenter and can be rotated into having a plane of symmetry. It is meso. The trickiest part about mesomolecules is if you were to look at these 2 molecules, you might be tempted to say that these 2 molecules are enantiomers. They're lined up the same direction, and all of the wedges and dashes have changed their orientation. And you would be correct in that respect, except for one thing. These are the same molecule. I've now drawn the same molecule 5 total times. To prove it to you, if we rotate this molecule like a steering wheel, we can bring that dash group down to the bottom right and that wedge group up to the top left. These are identical molecules. So one last mnemonic is molecules that look like they should be enantiomers, but the enantiomer is really identical. So one other trick you can keep up your sleeve for later, a molecule can only be considered to be meso if that molecule is structurally palindromic. Do you know what I mean by that? Do you know what a palindrome is? It's a word that's written the same forward and backward, like the word mom, M-O-M forward, M-O-M backward. Same word forward and backward. If a molecule is structurally palindromic, it's the same forward and backward, carbon, OH, OH, carbon, this molecule then might be meso. All meso molecules will be structurally palindromic like this. But be careful, not all structurally palindromic molecules are meso. Most of the time they'll just be chiral, but sometimes they will be meso. If you need a brief refresher later on in this course, I have a playlist down below where I've excerpted each term specifically, so you can look at just a short video of just that one term. Go get 'em, ninjas.